Alrighty, Mr. Gatekeeper here. I'm very excited to be making these series of videos. And before I start, I'd like to say these are absolutely, completely freestyled. They are not planned really in advance. I'm coming directly off the old dome, as they say, straight off my mind. I'm not going to organize these systematically. I'm just going to freestyle the whole thing, and this may or may not make it on YouTube publicly, but just in case it does, I am making these for a really good friend of mine, one of my best friends that I met back in 5th grade, and he has shown some interest in wanting to learn basically what I do, and which I'm very excited that he has. Me and him have done a lot of business ventures in the past, and we've been very successful with a few, and so it's really cool that he's showing some interest. So basically, we're going to call him Mr. Astra, A-S-T-R-A, Astra Damasta. That's his handle. And he is currently not a CB operator yet. He may never be. This just may be something he gets into. He may show interest in wanting to get into the hobby in the future. I don't know. But he has shown some interest in wanting to learn what I do, how to build amplifiers, how to repair them. That's the main thing we're looking at with this. And me and my buddy used to do some programming on the computer back in the days. So I'm going to kind of relate this to that, because building amplifiers or building electronic circuits are kind of similar to programming. You have building blocks that you use, which are components, and using the components in a perfect blend mixture, you create circuits. And that's kind of the same thing that programming is. You have a certain amount of code that you can use, and use that code in a perfect mixture to create a program or to create a script. Alright. This is not going to be done in a sense of widespread electronic circuits. I'm going to explain this in a sense to only building RF amplifiers. So, as you see here, these are the 5 building blocks, as I see it, of building an amplifier. Okay, and before I start, one more thing I do want to say. My buddy Astra is at the same exact place that I was at about 6 or 7 years ago, around that time. The same exact place. He has the same exact electronic knowledge that I had, which is hardly nothing at all. But we had used a soldering iron at one point in time. Back when we were younger, we modded Xboxes with the Executor 3 chip. And we wasn't successful with the first one, but we were with the second one. I'm sure he remembers that. But at the whole time, we did not actually know how to solder. Okay, and that was very evident with my first amplifier that I ever built, which I still own. And also back when we were around 13, 14 years old, 15 years old, we also played around with trying to follow schematic diagrams on building circuits to make the old school landline phones do different things. But even then, I halfway didn't get the circuits right I tried to make, and I still did not understand how to solder. I was actually trying to melt the solder onto the object that I'm trying to solder and let the solder drip onto it. I didn't actually understand how to properly solder. We're not going to cover that in this first video. I'm going to wait and cover that later on when I have a soldering iron in front of me. So these are the 5 building blocks: resistors, capacitors, diodes, inductors, and of course transistors, or we like to call them pills. Without the transistor, you have no amplifier. Okay? Without an inductor, you have no amplifier. Now, we could also say, in a sense, without diodes, we'd have no amplifier too, because the transistor has diode junctions in it. But you can get away with building an amplifier without a physical diode in the circuit. But diodes are a very, very important component. Most keying circuits use them. Okay, capacitors you gotta have to build an amplifier, and resistors you gotta have to build an amplifier. You may be able to pull off an amplifier circuit without a resistor, yes, but most amplifier circuits do use resistors. So these are the 5 building blocks that we're going to cover in this first video. Okay. Now on hand, I am going to teach you, Mr. Astra, how to read the value of resistors, or how I currently read it without using a calculator, without using a chart or anything. We're going to talk about capacitors, what they do, and like I said, I'm going to describe these components as what they do in an amplifier circuit, okay? And I'm not going to try to get, too in depth. I want to cover the basics here. I don't want to, I'm going to make sure to stop myself if I get a little bit too deep. What are you chewing on down there, man? Sorry, I got a little 4-legged animal right here. And yes, I probably will be smoking a couple of cigarettes during this, because I am a smoker. And yes, I know it's a very, very bad habit that I do need to quit. But I'm just being real with you. I'm relaxing here before I go to bed. Alright. Give me one moment. I'm going to press pause and I'll be right back, and we'll start with resistors. Alright, actually, before we get on resistors, one thing I did want to do is just show you an example of all these components, okay? Alright, here is a resistor, and I'm sure you already do know that, Mr. Astra, Dumasta. Alright, there's an example of a resistor. They can look a lot of, and that's another thing, these components I'm showing you, they can look a lot of different ways, a lot of different appearances. But a lot of times a resistor will be a cylinder type object like this, or a square. Although, like I said, there are many different types of physical packages for them. And most of the time you're going to see a color code, as you see here, which we'll talk about in a second. Okay. Here is an example of a capacitor, which you will see these particular type a lot in the RF amplifiers we're going to be building and repairing. These are, and like I said, there's many different types of capacitor. These particular ones are called a silver dip mica. Silver dip mica. These bad boys right here are designed to withstand a lot of heat and stay strong, let's put it that way. Okay, so that's a capacitor. Alright, here's a diode. A lot of times, or the majority of the times, you're going to see a diode, and how you're going to know it's a diode is going to have a stripe. You see that gray stripe on it? It's going to have a gray stripe just like that. So that is a diode. They come in tiny, tiny packages and real big, big packages. Next is an inductor, or a choke. I should have wrote that on there. Inductor. Alright, inductor or choke. A choke is just a kind of a slang name for an inductor, or a type of inductor. Alright, what consists of this inductor is a particular type of material that's in a bead. You see, that's like a cylinder bead. And of course you can see the wires wrapped around it 3 times. This bead, the material of this bead is called ferrite. Ferrite has different types of makeup, but you're mainly going to see 2 types of ferrite in the RF amplifiers we'll be building, and that's it. Mainly 2 types. This type is a shiny type. I'm not going to get deep into that. We'll get into that later. But this is a choke or an inductor. You got to have these. Without these, you have no amplifier. You have to have inductance. And last but not least, the good old transistor. And this particular one is a blown transistor. I don't want to carry around an $80 transistor in my pocket. So this is a transistor. We also call them pills for short. And if you take away the leads from them and kind of look at it far off, it kind of looks like a pill. Okay, this right here is the heart of the amplifier. This device is what is actually amplifying the RF signals. The transistor. Alright, now I showed you an example of the 5 building blocks. 1, 2, 3, 4, 5. We're going to start off with the resistor. And before I get started, I want to explain that every single device on here, except for the diode and the transistor, have readings, have measurements. You can measure these devices, the resistor, the capacitor, and the inductor. They all have units of measurement, just like a liter of water. You know, units of measurement for water. These have units of measurement for each of these 3 devices, which is very important. The exact measurement of each is what's going to allow the amplifier to be tuned, to be working the way it's supposed to be working, each and every little one. And we'll talk about measurements, the unit of measurements, later. We're going to talk about the unit of measurement with the resistor first, and that's what we're going to do now. So I'm going to press pause and write down some more notes. And like I said, this video is designed for somebody that absolutely knows pretty much nothing before they're starting. If I would have had somebody show me a video like this when I started, oh my God, I would be probably a lot further than I am right now, for sure. But I was blessed enough to have people that did help me, and I'm very thankful for that. Because you can get on the internet and search up this stuff and get real deep with it. But what I'm attempting to do right now is to plant those first seeds that will sprout into you being able to actually to study up on each component, which is something I should still be doing now. I should still be studying deeper into these components, and just taking it back to the simple things and seeing what I've missed, you know, maybe what I've left out, because it just is what it is. This is the best way to start with this stuff, is with these building blocks. Alright, man, I'll be right back. Alrighty. Alright, don't laugh when you hear this, but I'm telling you, this is a way that a guy taught me a few years ago, 4 or 5 years ago, on how to read resistors. There is a lot of people out there even now that's been doing this for many years that still have to look their resistors up on a chart. Just because of this simple method, I have not looked up a resistor in a long time. I can literally look at a resistor, and most of the times in my head figure out the exact value that it is just by looking at it. Sometimes I just simply use my fingers which I'm going to show you now. Alright, resistors. The measurement of resistors is ohms. Ohms, resistors are a powerful, powerful component. This is one of the very first components ever made in electricity. Resistors are measured in ohms. We are mainly going to be measuring them in ohms and kilo ohms. But we'll mostly call it, like, we'll abbreviate the kilo ohms with a K. But they're measured in ohms. Okay, and Ohm's law is something we'll get into later, which is pretty much the buildup of all electricity, all electronic circuits. Alright, here's how the saying goes. As you can see, big boys race our young girls, but violet generally wins. And I hope I spelled everything right. I don't think I spelled generally right, did I? I think it's G-E-N. I think it's A. But I ain't the best at spelling. But you get the picture. Don't make fun of me for that. I ain't the best at spelling. Big boys race our young girls, but violet generally wins. Okay, this is a numerical system. Big. You see how I've got the first letter of each word underlined. Okay, these are just to help you remember to look at the very first letter of each word. Big. The B equals black. Since big and boys have the same letter, this is just something you have to remember in your head, because there are 3 B's in this. But luckily blue is all the way down here, so you'll always know that's blue. Up here at the top, and I guess the reason why I was able to remember this real easy, one of the most common resistors we're going to be using is a 100 ohm resistor, which I didn't even bring it with me. But the 100 ohm resistor has black and brown in the color code. So I quickly remembered what was what. Okay. Big equals black. Alright. Boys equals brown. Race equals red. Hour equals orange. And you see what's happening here. It goes on. Young, yellow. Girls, green. There are 2 G's, but we don't usually use gray that much. But you'll always remember gray's down at the bottom. Okay, girls is green. Butt is blue. Violet is violet. Purple generally is gray, and wins is white. I don't think I've ever really used a resistor with white in it, but maybe once or twice. Alright, so it's just as simple as this. It goes 0, 1, 2, 3, 4 all the way to 9. Okay, I think you see what's going on here. Alright, we'll be using mainly 2 types of resistors, a 4-band and a 5. We won't talk about 5-band resistors right here, okay? There's nothing to them. All they are is they add an extra value. 5-band resistors are what you call precision resistors. They just help you get closer to the exact number that you're needing. So we're going to be dealing with 4-band resistors mostly. And they're laid out like this. And see, it's usually going to be pretty easy to tell which one's your first band, because as you see right here, the gold at the end is a little further away from the first 3. You see what I'm saying? Okay. So the very first stripe is going to be a value. So we're going to come over here and look at our chart, okay, or remember it in our head. The second is a value also. So you're going to go over to the chart and just add the next number beside it. Okay. Then the third, this is the easiest way I've been able to remember this. The third band is going to tell us how many zeros to add to it. Alright, there's going to be some instances it's going to tell us how many zeros to take away from it, but we're not going to go over that right now. Okay, we're going to go through the basics first. So the third band is going to tell you how many zeros you add to it. Alright, the last band is the tolerance, and all that means is this. It's going to be usually a 1%, 2%, but the most common that you're going to see is a 5%. That's what the gold right here represents. Gold equals 5%. And all that means is, let's say for example we have a 100 ohm resistor with a gold band. That means that that's a 100 ohm resistor with a 5% tolerance, meaning that resistor can be 5% higher than 100 ohms or 5% lower. So you can sit there and have 100 ohm resistors or 1,000 100 ohm resistors, and all of those resistors are not going to be the exact same 100 ohms. They're going to be a tolerance level. This particular one, like this resistor, is a 5% level. When you get to more expensive resistors, they will be closer to like 2% or 1%. You know, of course, if you had a 1% resistor, 100 of them, most all of them are going to be the same value. Very close. They're going to be 1% off from each other. So 5% are used in circuits where you don't, where a precise measurement is, you don't have to have a precise measurement. You'll even see some resistors that are even 10%. And if I remember correctly off the top, okay, I'm getting too deep. I'm not going to get real deep. We're just going to be using mostly what we're going to cover, mostly what we're going to be using. So that's all that tolerance means, and that really doesn't mean much to us. We really just can ignore that right now. That really doesn't mean much at all to us, okay? I've never had an issue where the tolerance was really important to me, to be honest with you. I could sit there, if I needed an exact, number, I could sit there and test a couple of them till I found like exactly 100 ohms or exactly 95 ohms. But I've never had to do that. So mainly we're going to be looking at the first three stripes. All right. So let's get into it. I've got a couple of resistors here we're going to go through. And after I get done with this, I'm going to go ahead and stop the video and I'm going to upload it. And that will be series 1. Alright. So, the first resistor, we're going to use the one we were just looking at. Okay. This resistor is a brown, black, orange. Okay. We're not even worried about the fourth stripe. We're going to look at these three. Brown, black, orange. Alright, so here's how we do it. I'm going to write number 1 for the first resistor. Brown. Alright, the color brown equals 1. Okay. See, when you get into the big boys, that's right there's for your memory. Like if you didn't have nothing to look at, you just need to remember. Alright, if it equals 1, brown equals 1. Let's do this in my head and use my hand. Big, I always use my fist for big because big has 0 value. Big boys, 1. Brown equals 1. So let's write down 1. Alright, the next color is black. Big. Black equals 0. See, black equals 0, so we're going to add a 0. Alright, the next color is going to tell us how many zeros to add to the number, the value we've already got. Orange. So I'm not even going to look at the chart. Over here with my hand. Big boys. Race hour. See? Big boys race hour. Hour equals orange. Equals 3. Orange, 3. So we're going to add 3 zeros. 1, 2, 3. Alright, so we can tell this is 10,000. So this equals 10 kiloohms. 10,000 ohms, or 10K. Alright, let's put that resistor away. And they're all going to be the same ease. They're all easy to figure out when you use this. Alright, here's one that I use a good bit, especially with some attenuators on 3 pills, 4 pills, 5, 2x4, stuff like that, amps. Alright, let me turn it this way just so we can look at it in this orientation. We have yellow, purple or violet, black, and then gold. But we're not going to look at the gold. We're looking at these 3. Yellow, purple, black. Just always remember purple means violet, okay? Yellow, purple, black. Yellow. Big boys race our young. Young, yellow, that equals 4. So I already knew that just by using my hands. So you don't need to even look at this chart. You just, basically this chart right here is just for you to look at a few times. Just to get it in your head and to remember which color associates with which word. Which is pretty easily remembered because we're mainly going to be using resistors that pretty much go from violet up most of the times. Okay. So that's just about the only thing you have to remember, which is 10,000 times better than having to remember how to do this by numerical values using a chart and all that stuff. Alright, so the first value is yellow, which equals 4. Violet, big boys. Alright, let me start over. Big boys race our young girls. Now I'm using one hand, so I'm going to start over. But, which equals 6. Violet, 7. 4, 7. See? Violet equals 7. Alright. Those first 2 are the value. So let's see how many zeros we add to it. Alright, it equals black. Alright. Big. Black equals 0. So how many zeros do we add to it? We add 0 zeros. So we add no zeros. So this right here is a 47 ohm resistor. 47 ohm resistor. Yes, sir. Alright, let's put that down here. Here's a pretty cool one. I haven't seen many of these resistors. Oh, wait, hold on. I'm wrong. I'm thinking of a different type. But, these resistors, I haven't used many of these, but they definitely can be used in what we do. I just basically grabbed some resistors to bring with me, literally within like 3-4 minutes. Alright, so this one is a green, blue, black. From the last one we already can tell this right here is only going to be a 2 value resistor because that black means to add no zeros to it. So let's get started. Green, blue. Big boys race our young girls. Okay. Girls is green. 5. 5. Blue. Big boys race our young girls' butt. 6 equals 6. Alright, the last value is black, so black equals 0, so we add no zeros to it. So this is a 56 ohm resistor. Alrighty. Alright, now here's a pretty cool one. I just noticed I got one more resistor over there. So we'll do 2 more examples. Alright, here's a pretty cool one right here. Alright, this one is red, black, brown. Red, black, brown. Alright. red. Big boys race. So that equals 2. Race red equals 2. Alright, so this is starts off with a 2. Black. Alright, this is something that you need to remember. Now black is in the value portion. See, the first 2 stripes are the value, not how many zeros we add. So since we have a black in the value portion, then it holds a value of 0. So we have to add or write down a 0 in the value portion, okay? Because it is in the first 2 stripes, which is the value. We're basically just writing down the number for each stripe. Alright, the third stripe, how many zeros we add to it, is brown. So let's see how many zeros we add to it. Big boys. See, we're already there, brown. Brown equals 1, so we add 1 0 to it. So this is a 200 ohm resistor. Booyah. Alright, last but not least, here's a pretty cool one. Alright, this is a little bit of smaller resistor. That's something else too I didn't want to get too deep into now. But of course you'll see different size resistors. And the different size shows you basically how much heat they can handle. It's all about the heat. And what makes heat? Watts. Watts makes heat. So these are the type of wattage. This particular resistor is a 1/2 watt resistor. All the other ones I showed you all already, these were 2 watt resistors. So you can imagine that a 3 watt would be bigger. I haven't seen many 4 watt ones, but a 5 watt is like 4 times bigger than this resistor in size. So the bigger the resistor, usually the more wattage it can handle, the more heat it can handle. Okay, we'll get into that more later on. I just wanted to add that since this resistor is a smaller resistor. Alright, so this is the 5th resistor. We have brown, black, red. Brown, black, red. Alright, the first 2 is the value. Big boys. Brown equals 1. So it starts off with 1. Alright. Black. Here we go again. We got a black in the value stripe. So we're going to come up here. We already can remember now, by now, black equals 0. So that means we need to write down a 0. Alright. Red. Big boys race. Race red equals 2, so we add 2 zeros to the 10. So we have ourselves a 1K ohm resistor, a 1K resistor. We use these resistors a lot. I do, particularly. I use these resistors on my LEDs. That's a good value to use on the LED. And we'll get into that later on actually what resistors do. Okay, I wanted to kind of start off with measurements first when it comes to the actual resistor, and we'll get a little bit deep with what they actually do. And that's another thing, you can learn to build an amplifier without really understanding nothing. Anybody can watch a video, anybody can figure out how to put all of these components together and actually build an amplifier without knowing. You can sit there and take someone off the streets and don't even know what nothing is, period, and teach them how to build the amplifier, but not even know what the components are or what they do. But trust me, learning what these things do and learning what they are is very handy. Because even when you're building amplifiers, you're still going to come into issues sometimes where you need to troubleshoot. Because you may build an amplifier and something isn't working correctly. Because no, sir, I'm not going to sit here and lie to you, Mr. Astra, and tell you every time you build an amplifier it's going to work first off. Usually when you first start up, now you got a good teacher like me, now you may have some good luck. But my first 4 or 5 amps I built, zip, did not work. But luckily now, I rarely have an issue when I do build an amplifier of it not working. Sometimes I may need to make some adjustments, but I've got to the point now where pretty much every amp I build is going to work the way I want it to, because I've got to that point to where I've done enough of them. But so here is Resistors, my friend. So take any notes if you need to, or anybody else watching this. And I've been recording for 35 minutes, so I'm going to hit the stop button on this. I don't know if I'm going to do another one tonight or not, but next we will go over capacitors. So we'll be back.